This is the first video for Chapter 9. Now, Chapter 9 is all about a concept known as ideal gases. And ideal gases are derived from a theory known as kinetic molecular theory. Kinetic molecular theory is basically composed of 5 key postulates. So I'm going to start by discussing what those are. The first is that gases continuously move in a straight line until colliding with a wall or another molecule. So it's saying that gases are going to continue moving, and they move in a perfectly straight line, and the only thing that will stop them from continuously moving in that straight line is colliding with either the walls of the container that they're in or colliding with another molecule. The second postulate is that the volume of gas molecules is 0. The third is that gases exert pressure when they collide with the walls of the container. The fourth postulate is that there are no interactions between gas molecules. And the last is that the average kinetic energy of the molecules is proportional to the temperature. Now, the first 4 of these in particular are assumptions that are not actually correct. Gases can move in, slightly changing paths. They don't have to move in perfectly straight lines. Obviously, a molecule has some kind of a volume, right? The atoms have to take up some kind of space. Effectively, pressure, this is a fairly decent assumption as to why pressure occurs. So number 4, there are no interactions between gas molecules. That's also not true. There's always going to be intermolecular interactions, but 1, 2, and 4 in particular are assumptions that are made because, although they aren't technically correct, each of these effects are so incredibly minuscule. Compared to the volume of a container, for instance, the volume of each individual atom is so small that it's known to be negligible, which means that it will have no effect on any kind of final calculation. Likewise, the interactions between gas molecules, because gas molecules can spread way out and they move extremely fast, the interactions are so incredibly weak and minor that they have no significant effect. So if we were to try to include these in some of the calculations you'll see in this chapter, it would make the calculations far more difficult with no significant effect on the final answer. So we use some of these assumptions to simplify the calculations. And that's the difference between real and ideal gases. So you'll hear both of those terms in this chapter. So real gases basically are gases that are the actual gases that exist in the real world. So for instance, they do have volume, and they do have intermolecular interactions. But ideal gases are these kind of perfect, idealized versions of gases, where they're basically just tiny spherical balls with no volume that perfectly ricochet around in a container. And that's going to be the key to a lot of the kind of equations and a lot of the theories that we're going to look at moving forward.